Hello dear students, so today we will be starting the chapter 5, continuity and differentiability. So hope you all are doing well. So please share with your friends and try to solve as many problems what we are discussing here and prepare well for your exams. So let's start. So let's start our first problem. Examine the continuity of function f of x equal to x cube plus 2x square minus 1 at x equal to 1. Okay, so we know that function f will be continuous at x equal to a if limit x tends to a minus f of x equal to limit x tends to a plus f of x equal to f of a. So that is, see if we have the limit, okay, so if we are taking x equal to 1, okay, then our limit will check the continuity for x tends to 1 plus and x tends to 1 minus. What it means? 1 plus means if this is 1, then we'll check for the values more than 1, that is 1 plus. Also we'll check for the values less than 1, that is 1 minus. Okay, so if we are getting the same values for both, then we can say that the function is continuous. If both are different, then it is not continuous. Okay, so let's see it. So first of all, f of x equal to x cube plus 2x square minus 1 at x equal to 1, right? So suppose limit f of x, our limit is 1 plus, okay, 1 plus means it can be 1 plus any number, okay, so more than 1. So suppose I am writing it as limit h tends to 0, okay, I am just adding a new variable, h can be any number, so here we are taking h tends to 0, okay, so our function is x cube, right? So in place of x I am substituting 1 plus h because it is x tends to 1 plus, okay, so it is more than 1 plus 2 into 1 plus h square minus 1. So if h tends to 0, that means if we substitute 0 in place of h, what we are going to obtain? 1 plus 0 square minus 1. So this value is what? 1 plus 0 is 1. 1 cube is 1 itself, right? Okay, plus 1 plus 0 is 1. So 2 into 1 is 2. So 1 plus 2 is 3. 3 minus 1, 2. So this is equal to 2. I can write it as 2. Okay. Yes. Now similarly, we are going to write limit f of x, x tends to 1 minus. Okay, so what will be the value? H tends to 0, okay, 1 minus h the whole cube. So here it is 1 minus because we are taking the values less than 1. Okay, so less than 1 means there will be a certain value which will be reduced from 1. That's why we are just subtracted h. H is an unknown variable, can be any value from 1. Okay, 1 minus h square minus 1. So this is also equal to what? This will be also equal to 2 because 1 minus 0 whole cube is what? 2 into 1 minus 0 square minus 1. So this is 1 plus this is 2 minus 1, that is 2. Okay, clear? Now from this what we have got? What is our conclusion? So from this we can say that limit x tends to 1 plus f of x is equal to limit x tends to 1 minus f of x. Okay, yes, clear. So in the question they have given if f of x equal to x cube plus 2x square minus 1 at x equal to 1. Okay, so we have to check if at x equal to 1 whether it is continuous or not. That is what we need to check. So just put 1 in place of x. So f of 1. So we got this one and this one equal. Now just check for 1 as well. Okay, so we have, if we are taking this as 1, we checked for these values and these values. Now we are going to check for 1. Okay, so 1 cube plus 2 into 1 square minus 1, that is also 2. So we can say that f of x is continuous at x equal to 1. I hope it is clear. Okay, so let's see our next problem. So this is our condition. If x is greater than or equal to 2, then our function is 3x plus 5. If x is less than 2, then our function is x square. So at x equal to 2, so we are going to see the left hand side limit of 2 and right hand side limit of 2. Left hand side limit means LHL. RHL is right hand side limit. So we are going to check whether these two functions will give us the same value for checking the continuity. Okay, so let's see that if both gives the same value, then we can say that f of x is continuous at x equal to 2. Clear? Okay, so let's start. So we know that for LHL at x equal to 2, LHL equal to limit x tends to 2 minus, LHL means towards left. Okay, so that will be 2 minus. Okay, so for 2 minus we have given, like, if x is less than 2, our function is x square. Okay, so it will be x square. Okay, now so for that case, what we usually substitute? For the last problem we have done that h tends to 0, 2 h tends to 0, 2 minus h the whole square. Okay, so just expand this one. So this will be a minus b the whole square form. So this is going to be 2 square minus 4h plus h square. Okay, this is what we will obtain. So if we put 0 in this function, this term is going to be 0. Okay, this is going to be 0, only this will left. So this value is going to be 4. Clear? How to get this value? Okay, same thing what we done for the problem before. Okay, now this is our LHL, so that is 4. Let's see the RHL part. Okay, RHL will be limit x tends to 2 plus, so what is our function? For x greater than or equal to 2, our function is 3x plus 5. So 3x plus 5. So just do our h tends to 0. Okay, 3 into 2 plus h plus 5. Okay, so what is this value? If h is 0, then 3 into 2 is 6. 6 plus 5 is 11. So we are going to get 11. Okay. Yes. So from this, what we can say? LHL value was 4. RHL value was 11. So LHL is not equal to RHL. Okay. Hence, we can say that f of x is not continuous at x equal to 2. So this is our next problem. F of x equals 1 minus cos 2x by x square if x is not equal to 0, 5 if x equal to 0. So we are going to check whether f of x is continuous at x equal to 0. So let's start. LHL equals limit x tends to 0 minus. Okay, so 0 is the point on which we are checking the continuity. Okay, so if it is 0 minus, then our function is 1 minus cos 2x by x square. So we will be substituting h tends to 0. 1 minus cos 0 minus h, which is same as h. Okay, so 2h, fine, divided by h square. Okay, now we have, if for cos 2 theta equal to 1 minus 2 sine square theta. Okay, excuses. Okay, so cos 2 theta is going to be 1 plus 2 sine square theta. Okay, so we are going to substitute that. So it is going to be limit h tends to 0, 1 minus 1 plus 2 sine square h divided by h square. So 1 and 1 will get cancelled. 1 minus 1 is 0. So what we will get? So here it is going to be limit h tends to 0, sine square h divided by h square. Sorry, there is a mistake. Okay, yeah, that's fine. So this can be also written as sin h the whole square. Okay, so it will be like this. Oh, there is a 2 behind. We have a 2. Okay, so sin h by h is 1. Okay, so this whole term is going to be 1. So our value will be 2. Okay, this is how this 2 obtained. Okay, now we'll check RHL. So RHL will be limit x tends to 0 plus, right? So that is 1 minus cos 2x divided by x square. Okay, so limit x tends to 0, 1 minus cos 0 plus h divided by 0 plus h the whole square. So we can replace this cos 2h with sine, right? So this is going to be finally limit h tends to 0, 2 sine square h by h square equal to 2. And if we substitute f of 0 in our function, f of 0 value is 5, which is already given in the question. Okay, so LHL equal to RHL, but which is not equal to f of 0, right? All three should be same, then only we can say that the function is continuous at a particular point. Here it is 0. So at x equal to 0, we cannot say that f of x is continuous, because LHL and RHL gives the same value, but f of 0 is different. Okay, so definitely that line will not go through the same pattern, right? Some fluctuations will happen there, because only this LHL limit and RHL limit are going in the straight way, but 0 is not 2. Okay, point 0 is not 2, which is, if suppose this is 2, 0 is 5. Okay, so here when it comes here, it is going to be like this. So definitely we cannot say that f of x is continuous. I hope it is clear. Okay, so this is our next problem. We have two functions, 2x square minus 3x minus 2 divided by x minus 2 if x is not equal to 2, okay, and 5 if x equal to 2. And we have to prove that, not to prove, we have to see whether f of x is continuous at x equal to 2. So let's start doing. So first of all, LHL, that is limit x tends to 2 minus, okay, 2x square minus 3x minus 2 divided by x minus 2, which is equal to limit h tends to 0, 2 into 2 minus h the whole square minus 3 into 2 minus h minus 2 divided by 2 minus h minus 2. Okay, so this is going to be limit h tends to 0, 8 plus 2h square, 8h minus 6 plus 3h minus 2 divided by minus h. I have just simplified it. Okay, just expand and simplify. Okay, so this is going to be what? So just see here, 8 minus 6 is 2, minus h plus 3h will be minus 5. Okay, so 8 minus 6 is 2, right? So 2 minus 2 is 0, so these three terms cancelled. So 8h plus 3h is, so this can be written as h tends to 0, 2h square minus 5h divided by minus h, that is equal to limit h tends to 0, h into 2h minus 5 divided by minus h, which is equal to 5, right? Because if we substitute 0 over here, this term will get cancelled. Okay, so we'll get minus 5, okay, and down we have a minus. Okay, so both minus will get cancelled, we'll get 5. Now we'll check for RHL. RHL equals limit x tends to 2 plus 2 2x square minus 3x minus 2 divided by x minus 2. Okay, so limit h tends to 0, 2 into 2 plus h whole square minus 3 into 2 plus h minus 2 divided by 2 plus h minus 2. Again expand this one, so it will be limit h tends to 0, 8 plus 2h square plus 8h minus 6 minus 3h minus 2 divided by h. Okay, so here also when we cancel the terms, we'll get it as 2h square plus 5h by h. You try to solve, simplify it. If I say again and again, what will happen? You won't think. Okay, just think and simplify this term. Equal to limit h into 2h plus 5 divided by h. Okay, so this will also give us 5. Okay, so f of 2 is what? Which is 5. That is given in the question. So LHL equal to RHL equal to f of 2. So we can say that f of x is continuous at x equal to 2. Okay, this is our next problem. F of x mod x cos 1 by x if x not equal to 0, 0 if x equal to 0. So we have to see whether f of x is continuous at x equal to 0. Let's begin. So LHL, limit x tends to 0 minus mod x cos 1 by x. So we can write it as limit h tends to 0, 0 minus h cos 1 by 0 minus h, right? This can be limit h tends to 0, h into, in place of this we'll get mod 0 minus h will be 0 minus h will be mod minus h, that is equal to h. Okay, so h cos 1 by 0 minus h is minus h. Okay, so when we substitute h as 0, so this is going to be 0, right? So there is a quote that is 0 into an oscillating number between minus 1 and 1 will be 0. So this is an oscillating number. It always oscillates. Okay, so 0, when we substitute 0 here, 0 into an oscillating number will come, right? So it is going to be 0. So now let's do it for RHL. So limit mod x cos 1 by x, sorry, x tends to 0 plus, right? Okay, so limit h tends to 0, mod 0 plus h cos 1 by 0 plus h. So again this is going to be limit h tends to 0, h cos 1 by h. So the same thing, 0 into an oscillating number, okay, between -1 and 1 will be 0. So this is also going to be 0. Now let's check what is the value of f of 0. So for f of 0, in question it is given that when x equal to 0, the value is 0. So LHL equal to RHL equal to f of 0. Hence we can say that f of x will be continuous at x equal to 0. Okay.